Welcome friends. Today I am going to discuss about surge protective devices. So the surges are a very much unavoidable incident in an electrical power system. This could be caused because of the external parameters or external causes or internal causes. So let us understand what is surge and how it is created and how it impacts the electrical power system and how to protect the loads from these surges in this video series. Let us begin with what are surges. Simply speaking, these are transient high voltages due to either it is the external causes like lightning or the internal causes like a grid switch on or the capacitive banks switch on or switch off or the heavy loads getting on and off. Because of this the surges could happen, so which cannot be avoidable. So this is the integral part of an electrical system, but it could damage electrical devices, and the voltages which appears during these surges are very high in nature. So we have to have a protective device to protect the loads and the power system from these surges. So let us see what are the causes for these surges or the transient over voltage. So as I told you little earlier, so it could be because of the external parameters like lightning or the electrical switching events. So the electrical switching events like grid switching or the switching large capacitor banks to on or off, the electrical accidents, the line to line contacts or the line to earth direct contacts or the heavy motor or the loads getting on and off or the few internal external parameters which could cause up to 35% of the transient over voltages, and 65% of the remaining surges are created from the loads like microwave oven and laser printers, copiers, and electrical motor or electrical appliance. Even when you switch on and switch off the light, because of the inductive nature, you can see the spark which is producing there. That is nothing but the voltage, high voltage between the contacts of the switches. So these are the causes of the transient over voltages, and let us put it into very confined way that the direct strikes from the lightning or the indirect strikes from the lightning is the external causes of the transient over voltages. Let us understand what is direct strikes and indirect strikes in the upcoming slides. So the direct strike from the lightning, which falls on the lightning arrestor, so which we placed on the structure of our building. So the lightning falls on this lightning arrestor. The current flow takes place through the conductor, which is connected to the ground. And since we have a common ground, so the current flow goes back to the bus bar which we connected for the earthing, and it flows through the power system. So the nature of this direct strike current is 10 to 350 microseconds. So this is how we classify the types of surges, and 10 microseconds of rising time and 350 microseconds of 50 percentage fall time. So this is the nature of the surge current which appear during the direct strike. So this means it takes 10 microseconds to reach the peak value of the surge current, and it takes 350 microseconds to come down to 50% of the maximum current during this surges. Direct strike to nearby services. So here it is not falling on the in the factory or the building, but it falls on the transmission line, and the transmission line conductors carry this current, and the current would travel in two directions. So the current would be divided by two. So the maximum current is passing through towards the load side of current, and then the remaining current would go through the transmission line. The nature of this also, since it is a direct strike, we have 10 bar 350 microseconds. So that means 10 microseconds for rising time, 350 microseconds for reaching the 50% of the maximum current while falling down. The indirect strike near structure. So here we have the structure, or we have the organization here, and the transmission line is here. The lightning is falling nearby the structure. So because of this lightning, the high voltage or the high potential is created here. So this potential difference between this high voltage ground and the transmission line. So because of this, the current would flow in this direction, and this current, the nature of this current is like 8 to 20 microseconds. 8 microseconds for reaching the peak value, and 20 microseconds to coming back to 50% of the peak value. So this is the nature of this indirect strike. And the next one is the indirect strike near structure. It neither falls on the ground, or it neither strikes the structure, or it neither strikes the transmission line, but the lightning doesn't reach to the transmission line, but the impact which is created because of the lightning, it creates a inductive surface here. So because of this high voltage inductive surface and the transmission line, the potential difference will be created, and because of that, the surge current will pass through this the system. And the nature of this system, this fault also is 8 to 20 microseconds. So 8 microseconds for rising and 20 microseconds for falling to 50% of the maximum current. So this is indirect strike near structure. So altogether, it is put like this. So there is a direct strike, and there is the direct strike on the transmission line, and there is a strike near the utility or near the structure, and there is a strike which is near to this, and it is also passing through the earth conductor. So these are the different type of lightning impacts, or the surges, the causes of surges, which could impact the load and as well as the transmission line or the power system. So which we need to address, and which we need to have a protective device. This is the current and waveform which I am talking about. So you can see here we have 80 bar 20 microsecond waveform, as well as we have 10 bar 350 microsecond waveform. So this is due to direct strike, and this is due to indirect strike. So in the direct strike, it takes 10 microseconds to reach the maximum value or the peak value of this lightning current or the surge current, and it takes 350 microseconds to reach to the 50% of the peak value when it is falling. And for the 8 bar 8 bar 20 microseconds waveform, and this is because of indirect strike, where you can see here it reaches the peak in 8 microseconds, and it comes back to 50% of the maximum value in 20 microseconds. So this is because of indirect strike. Types of surge protective device based on this amount of time and where it strikes. We have different surge protective devices. The type 1, type 2, type 3 surge protective devices are classified. So the type 1 surge protective devices are tested with 10 bar 350 microseconds, because these are going to be used in the lightning erupting or the lightning strike areas, and these devices should able to discharge this high current during the lightning or because of this high voltage strikes. So the ability to discharge very high current to earth, providing high up voltage protection level, must be accompanied by downstream type 2 protector. The type 2 devices are used where we have an indirect strike 8 to 20 microsecond waveforms, and it is tested with these values, and this also is accompanied with lightning strike and the distribution line where the indirect strike could happen. Ability to discharge high current to earth and providing a medium up voltage protection level, designed for use in distribution panels located downstream of type 1 protectors or incoming power supply panel in areas where low pressure, low exposure to lightning strikes. So the type 1 is used mainly in where there is a possibility to get a lightning strike, and in parallel with that, or in conjunction with that, we have this the second type, the type 2 like protective devices also. So where the waveform could be 8 to 20 microseconds and the voltages will be not very high. It is a medium up voltage protection level. And the type 3 surge protective devices where we have the characteristics 1.2 bar 50 microseconds to 8 bar 20 microseconds waveform. This is called the class 3 protective devices. Usually we test this device with these values, and it is to have the ability to discharge the medium currents to earth, providing low up voltage. So first one, type 1, very high voltage, and then the type 2, medium voltage, and the type 3, low up voltage protection level, always installed downstream of the type 2 protection. After type 2 protection, we will have this type 3 protection, so which will be used to protect the sensitive equipment like computers and other electronic equipment. So these are the three different type of surge protective devices which we use in an electrical power system. Switching surges are the major cause for the voltage spike in an electrical power system. Already we discussed about the external factors. This is the internal factor. This is because of the contactor or relay or the circuit breaker operation. So where you connect the motor or a load using a contactor, or you are connecting a total installation to breaker. So when you are turning on or turning off the breaker, there could be the voltage spike, or the loads are getting disconnected or connected using contactors. Because of that also there could be voltage spikes. And switching off or switching on the capacitor banks and loads for the power factor correction or any other type of applications. And discharge of inductive devices where you have a huge transformer or motor. When it is disconnected from the load, then it discharges. When you turn off the devices, it discharges. And starting and stopping of load, fault or arc initiation, fault clearing or interruption, power system recovery from the power loss, and the loose connections in the terminals. So these are the few causes of switching surges which will create a high voltage in the electrical power system. So we have discussed about what is surge and what is the internally created surge and the externally created surges. The externally created surges, we have seen the nature of it, and the type 1, type 2, type 3 surge protective devices. In the upcoming video, we are going to see what type of devices are used to protect the electrical equipment from type 1, type 2, type 3 uh, type of faults or the surges, and how these devices are going to function. Thank you. Thank you for watching. Let us meet in the next video. Until then, bye bye.